Good morning, students. Myself, Pawar MS from KJ College, Kopargaon. Today, we are going to discuss our next rearrangement, that is a Bayer-Villiger rearrangement. So, in that rearrangement, we have to use aldehyde and ketones in presence of per acid. Then, formation of the ester or acid. So, we have to use ketone, then formation of ester, and then we have to take the starting compound, that is a aldehyde, then formation of acid. So it depends on the starting compound, then final product will be obtained. So let us we have to discuss here statement of Bayer-Villiger rearrangement. So, statement of Bayer-Villiger rearrangement: both aldehyde and ketones are oxidized to carboxylic acid and esters respectively in presence of per acid. This reaction is known as Bayer-Villiger oxidation or Bayer-Villiger rearrangement. So, Bayer-Villiger rearrangement also called as the Bayer-Villiger oxidation. So, in that rearrangement, the most important thing, that is a this is the important reaction, involves rearrangement at electron deficient oxygen atom. So this is the most important step. The rearrangement takes place at what? At electron deficient oxygen atom. That is the formation of your final product. So for example, we have to take here ketone in presence of per acid. So per acid means in acid we have to add one oxygen atom, that is a, for example, R C double bond O O OH. So addition of one oxygen, that is a per acid. So formation of your ester, that is your final product. So starting compound is ketone, then formation of ester. Then we have to take the starting compound as a aldehyde in presence of per acid, formation of acid product, your final product. So this is the general idea or view about the Bayer-Villiger rearrangement. So we have to discuss here mechanism of Bayer-Villiger rearrangement or Bayer-Villiger oxidation. So we have to take here ketone. See here, R C double bond O R, that is your ketone. This is your starting compound. So we have to take the per acid, means presence of the higher concentration of acid, means presence of higher concentration of H plus ion. So here carbonyl carbon, presence of the oxygen, here oxygen has presence of lone pair. So this H plus can attack on this oxygen, formation of R C double bond O H and R. So here this oxygen carries positive charge because of these bonding electrons used for the addition of this hydrogen. Then here increase the valency of oxygen atom and formation of the OH plus. So in next step, this bond can be used for the stabilization of positive charge over the oxygen atom, and in next step converted into the RCOH R. So how this formation? By using this double bond, this bond shifts on this oxygen atom, they stabilize the positive charge over the oxygen atom, and in next step we have to get RCOH R, but this carbon carries positive charge because of here deficiency of one bond. So this carbon carries three bonds, so carbon carries positive charge. So this carbon is called as electron deficient carbon atom. Carbon atom, why? Because of here formation of the carbocation. So In next step, we have to take per acid, your general reagent for the Bayer-Villiger rearrangement. RC double bond O OH. Here presence of the lone pair. So in that reaction, here we have to use this lone pair of this oxygen, because of this oxygen is attached to this hydrogen. So this is the electron deficient oxygen atom. So this here oxygen EH, and here presence of the carbocation. So addition of this oxygen on this electrophilic center. So this lone pair of oxygen attack on this carbon, then formation of the bond between this oxygen and this carbon. In next step, see here formation of RCOH R, then bond between this carbon and this oxygen. See here O, so this oxygen attached to this H, then O C double bond O R. Then let us see here, this oxygen carries 3 bond, 1 2 3. So this oxygen carries positive charge, because of here increase the valency of oxygen atom. In next step, we have to stabilize this positive charge by using this bond. So this CH plus this CH can shifts on this oxygen atom, then stabilize the positive charge over the oxygen atom, means minus H plus here use. So in next step, formation of RCOH, here R O C double bond O R. Here presence of the lone pair of oxygen. In next step, this is the important step. Here in this step, migration of alkyl group, that is a 1-2 migration takes place. So here we have to take this R or this R. Why? Because of both alkyl group are same. So we have to use the this R group or this R group. So this R group can migrate on this oxygen. At that time, this bond shifts on this oxygen atom. So this O minus C double bond O R, that is your carboxylate ion formation, and this is your the driving force of reaction. Let us see formation of RCOH. Here O R. So this R migrate on this oxygen. So oxygen attached to this R, and this O minus can be break. So again this carbon carries positive charge, and plus we have to get O minus C double bond O R. This is your driving force of reaction. So what is the driving force of that Bayer-Villiger rearrangement? This carboxylate ion, because of this enolate ion can be stabilized by using the resonance. So this is the driving force of reaction. In next step, simply tautomerism takes place. Tautomerism takes place, and then we have to get formation of final product, that is this bond shifts on this carbon. So formation of the carbon oxygen double bond, and we have to get formation of your final product, that is a ester. Here formation of the ester. Why? Because of we have to take here ketone. If we have to take here aldehyde, formation of the acid, but in starting compound we have to take the ketone. So formation of the ester as a final product. So this is your final product of Bayer-Villiger rearrangement. So this is all about the rearrangement of Bayer-Villiger rearrangement. See here, let us we have to discuss again Bayer-Villiger rearrangement. We have to take both aldehyde or ketone. So aldehyde or ketone oxidize in presence of per acid. So formation of carboxylic acid or a ester. So it depends on in starting compound, it is a aldehyde or ketone. Suppose we have to take aldehyde, so formation of the carboxylic acid, then we have to take ketone, then formation of ester. So overall reaction rearrangement known as Bayer-Villiger oxidation or Bayer-Villiger rearrangement. So this is the important reaction involves the rearrangement electron deficient oxygen atom. Simply protonation takes place, then electron division carbon atom form, and then addition of per acid, and 1,2 migration takes place, formation of the carboxylate ion, and simply tautomerism takes place. We have to get the final product of your rearrangement, that is a ester. So today we are going to stop here, and next rearrangement we have to discuss in our next lecture. Thank you very much.